Hi, Janie. All right, now we've got the notes for page P3 and P4, and then I will upload the answers to the homework, which is P5. So hopefully the last stuff made sense in terms of domain. And now we're gonna just step it up a little notch, but not too much. Okay, so in the last lesson we learned about domain. He's got a warm up here to go over domain again. I'm gonna skip the warm up because we've got that on the last set of notes and go straight to the actual problems. So the difference between these and the last ones is that you're gonna be actually solving an equation. And then when you solve your equation, you're gonna have to stop and check to see if the solution to your equation is part of the domain. So I don't think it's gonna be too bad. But so step one, so this is our first example. We're gonna have an actual little equation that we're gonna solve. Okay, but before we solve it, step one is determine any domain restrictions. So in other words, let's look at our first example. When we have a domain restriction, that basically means, are there any negatives inside of my square root possible? Like what do I need to make sure happens so that the stuff inside the square root stays positive? So just like we did for domain on the previous examples, I don't even care about the equals 3 at this point. I just want to look at this. And for my domain, I just want to remember that x has to be positive. So x has to be everything that's bigger than or equal to 0. Because I need everything inside that square root, which is just x, to be bigger than or equal to 0 or to be positive. So my domain is that x is everything from 0 to infinity. So that's the first part. You find your domain, meaning just make sure that anything under a square root is going to remain positive. Then go back to the problem and solve it. So step 2 says isolate the radical or square root on one side of the equation. Okay, sorry, I meant to put an X under here. This already has the square root or the radical isolated. So now my job is, how do I get that square root away from that X? How do I get that X out of there? So my third step is raise both sides of the equation to a power that will cancel the radical. Okay, generally, because we have square roots, that's gonna mean square both sides. Okay, take both sides to the power of 2, because the square root of anything squared is just that x. The square root and the squared undo each other. And what I have left is x equals 3 squared or x equals 9. That's step 4, solve for x. Just did that. And then my last step is check to make sure your answer is in the domain. He says this step is very important because it won't always work, in which case your answer is no solution. So for example, if somehow I got x to equal -2 in this problem, and I looked at my domain and I was like, wait, x can only be anything from 0 and up, then I would say there's no solution to this problem. But in this case, I got x equals 9. My domain is that x has to be bigger than or equal to 0, so that's fine. My solution is x equals 9. It works out. Most times, it's going to work out. Okay, so let's look at number 2. Actually, let's skip. Well, no, it's fine. Okay, number 2 is a little bit weird because it's a cube root. So actually, I am going to come back to that. Let's look at number 4. Okay, number 4, remember this 1/2 really means x to the 1 square rooted. So I'm looking at this. So let's go ahead and do it. First step, I'm going to keep referring back up to these steps if you want to keep looking back up at them. First step is find any domain restrictions. Well, all that I have in the square root is x, so I know that x has to be bigger than or equal to 0. So I know that anything that x equals has to be 0 or bigger. That's my domain. Now let's go solve it. Step 2 said isolate the square root. So that means this has to be alone on one side of the equation before I can square both sides. So I'm going to subtract 4 from both sides. So I have this. Once the square root is isolated, now I square both sides, or take both sides to the second. The squared and the square root undo each other, so I have x over here, and -4 squared is 16. My last step is check my answer to make sure that my answer is in the domain. Yes, 16 is anything from 0 bigger, so x equals 16 is my answer. Okay. In concept, it's easy. We're going to get some harder examples, but let's just keep going with these ones first. Okay, so remember this, I'm gonna rewrite because I just like looking at a square root better than a power that's a fraction. So let's first get the domain. This 3x has to be bigger than or equal to 0. So that means x has to be bigger than or equal to 0 when I divide both sides by 3. So my domain is 0 to infinity. So that's fine. Now let's go back to the problem, and my next step is isolate the absolute value. So that's my step 2 of my steps. It's not isolated yet, so how do I get the square root by itself? Is I divide both sides by 2. So I have the square root of 3x equals 9. Now I can square both sides. The square root of 3x squared is just 3x, and 9 squared is 81. Go solve this, divide both sides by 3. X equals 27. Is that part of my domain? Yup. So there's my answer. Okay, not too bad. I just wanted to see if I wanted to do one of these next. Okay, let's do number 6. I'll come back, but I wanted to just do the ones that look similar first. Okay, so number 6. I have a lot more to be concerned with, but it's okay. So I have all of this under the square root. So for my domain, I know that 10x plus 4 has to be bigger than or equal to 0. I know that the thing under the square root has to be bigger than or equal to 0. So let me solve this by subtracting 4, dividing both sides by 10. So x has to be bigger than or equal to negative 4/10. You could write that as negative 0.4 if you want. Or you could write it as negative 2/5. Either way, it doesn't really matter. And in interval notation, that would mean x can be anything from negative 0.4 to infinity. Okay, so that gets the domain. Now let's go do the problem. So remember that next step to actually solve this says isolate the absolute value. So I've got to subtract 10 from each side. So now I have the absolute value isolated. Now I can square both sides. So on the left I have 10x plus 4. On the right I have 4. Now let's go solve this. Subtract to get 0, divide by 10, I get x equals 0. Is that in my domain? Go check. Well, yep, negative 0.4 all the way to infinity. Yep, 0 is allowed to be in that domain, so x equals 0 is my answer. Okay, so now what do we do when the root is not 1/2? So let's go back to the front. So when looking at number 2, it's a cube root, right? Well, remember what we said about domain in the last set of notes is that if I have an odd powered root, the domain is all real numbers. X is allowed to equal anything. X can be anything. This is like all the different ways to write domain. X can be anything. It can be all real numbers. Like X can be anything. So this is my interval notation. So there's no restrictions on my domain. So that means I'm going to go solve that, and whatever I get is going to be my answer. I don't have to worry about whether it fits the domain or not because the domain is everything. So the next step would be isolate the radical or the root. It is isolated. But what's new is my next step says raise both sides of the equation to a power that will cancel the radical. Well, this is cube rooted. So I'm going to have to cube both sides. That's the only thing that's different in the solving process. Since it's not a square root, I can't square both sides. I got to cube them. So I'm going to get the cube root and the power of 3 undo each other, but over here I have 3 to the 3rd. So 3 to the x equals 27. Finish and solve it, x equals 9. Okay, so the only real difference there is that I'm cubing instead of squaring. So if we flip back to the second page, number 5, you might be able to even do that from scratch yourself. But the domain is, again, all real numbers, negative infinity to infinity, because I have a cube root, so there's nothing that y can't equal. Next step, isolate. So I get my 4 to the other side. Now cube both sides. 4 to the 3rd is, 4 squared is 16 times another 4 is 64. Solve, y is 32. Final answer. Okay, you might want to go try number 8 and then come back. Again, this is a power of a third, so nothing is restricted. My domain is everything. My next step is isolating this. So if you want to put this back into a root, that's fine. Isolating means add 9 to both sides first. Okay, get that 9 on the other side. Then divide everything both sides by 2. Now go ahead and raise both sides to the third. So I have 4x plus 5 equals 5 to the third, which is 125. Now go ahead and solve the rest of it for x. So subtract 5, divide by 4, x equals 30. All right, and the number 7 and 8 have a 1/4. So now we have a 4th root, which acts more like the square root because it's an even number. Oops, eek. Okay, so what I have here is 2x minus 10, 4th rooted. So when I think about my domain, I now do have to worry about 2x minus 10 being bigger than or equal to 0. I do have a restriction because of the even numbered root. So go ahead and solve this. I'm going to get x is bigger than or equal to 5. So x has to be anything from 5 and bigger. Now let's go solve. So let's isolate the root. Now we're going to raise both sides to the 4th. So we undo the root. I'm going to add 10 to both sides now, divide by 2, and x is going to equal 11 over 2 or 5.5, 5.5, whatever. Is that part of the domain? Yes, we're good to go. Number 9, maybe you want to try it and come back. I have a domain restriction. This has to be bigger than or equal to 0. So, whoops, x has to be bigger than or equal to negative 9/8. So negative 9/8 to infinity is what I'm looking at. Come back, let's isolate the root. So I'm going to add 16. Divide both sides by 4. And now I'm going to take both sides to the 4th. So I have 8x plus 9 out of the 4th root sign. 3 to the 4th is 81. Subtract 9 from both sides, 72. Divide both sides by 8, we get 9. Is that in the domain? Yup, so that's my answer. So that's it. I'm doing 2 things. I'm getting the domain by figuring out what the thing under the square root is allowed to be. And then I'm solving by isolating the root, taking the power, raising both sides to the same power that will make the root cancel, getting my answer, and checking that it's part of the domain. None of these had a domain issue, except when you go to the homework, number 10. So take a look at, when you are finished, take a look at number 10. Oh, wait. No, that didn't have a domain issue. Never mind. Number 10 had one thing where we had to flip the inequality sign. So number 10, I had a star. So if you have any questions, let me know. I think that was it. Everything else, like, I had the domain, and then the answer was still fine. Like, nothing gave you an answer that didn't work. So anyway, there you go. Hopefully it makes sense. I'm going to post this now, and yeah. Bye.